It's Tuesday, and today we're learning how to solve quadratics by completing the square. So far, you've learned how to factor and how to use the square root method. Factoring only works for nice, obviously factorable quadratics, and the square root method only works when you're missing that bx term. So those guys are very limited problems you can solve. Completing the square closes that gap. We are now able to solve literally any quadratic I give you. You're not going to want to because completing the square is not the nicest process for every quadratic, but for the most part, these guys will be pretty cool. All right. Also, this is a really cool lesson. In class, people actually ooh and ah when I teach this. I mean, that sounds like a lie, but legit, it's true. When I go through this process, people are like, wow, that's really cool. So I'm going to pretend that's being said at home while you guys are watching. Okay, so what's going to happen is you're going to have part of a quadratic, and we're going to move our problem around so that we have this set up. We're going to have the x squared term and the x term. And what you're going to do is you're going to forcibly pick a number so that I have a perfect square trinomial. Completing the square is finding a perfect square trinomial. We're going to factor that perfect square trinomial and then use the square root method. That sounds like a lot of work, but it's actually quite seamless once you start. So, given what you have, I'm going to show you mathematically what's actually happening, then I'll show you the process on how to actually do that. All right, so I'm given x squared plus 4x. So we're just going to go ahead and fill in on this square what we actually have. Hopefully remember that x squared is that big guy. And then x's are the long, skinny rectangles. I'm just going to go ahead and split it in half so I can make a square, not a long rectangle. Okay, so I'm going to do a 2x here, a 2x here, and a 2x here, and a 2x here. All right, so to complete this square, to make a square, I would need to have this section here filled in, which is 1, 2, 3, 4. I would need to add 4 on there. Well, if you notice what we just did multiplication in these algebra tiles. Well, right here we have an x and we have a 2. So this is technically x plus 2. Same thing over here, we have an x and we have 2. So we have x plus 2. If I were to factor this right here, I would get x plus 2 times x plus 2. Remember, if the first term's a square, the last term's a square, the middle is a double, then it's a perfect square trinomial, or what multiplies before and adds to before. And then, if it's the same thing twice, I can go down and write it one time, just squared. And this will allow us to do the square root method, and I'll show you how to do that in just a moment. Okay, so let's go ahead and do another one. All right, given this, I'm going to go ahead and fill in what I have. So x squared is that big guy there. 6x, I'm going to go ahead and split it in half and fill in 3x's here and 3x's here. What am I missing to complete that square? Well, I need this 3 by 3 box here, which is 9. Well, if I were to factor this, what multiplies to be 9 and adds to be 6? Well, that's 3 and 3. I just factored this x plus 3 times x plus 3. So I've just factored that. I forced the number so that I have a perfect square trinomial. Going ahead and filling this in, I now have this perfect square trinomial squared, so I can square root it. All right, so if we were in class, I would say, so who can figure out the pattern and tell me what it is? But alas, it's all me right here by myself. So the pattern comes from, this 4 comes from the dimensions of this box. Well, this is a 2 by 2, so it's 2 squared. This box is 3 by 3, so it's 3 squared. Oops, sorry, 3 squared. So how did I get that 3? How did I get that 2? Well, those numbers come from, I took this middle number and I cut it in half and cut it in half. So cutting 6 in half, I got 3 here and I got 3 here. So this number is 3 squared, because it's 3 by 3. This one here, 4, I cut it in half, so it became a 2 by 2. Okay, so the pattern, which sounds a little silly, is to find this number, you're going to take the b term, cut it in half, so half of 4 is 2, and then you're going to square it. So that's the process we're going to do mathematically, so let's go ahead and just work out several examples. and then you guys will be doing some homework. So if you want to see the directions written out, those are on the front side of the notes on the bottom, but I'm just going to go ahead and say the directions repeatedly as I work this out. So what you need to do is you need to have, firstly, x squared needs to have a 1 with it. So in this problem, I do have a 1, but if there was a number out front, you have to divide that, okay? I recommend always moving this number first. So you want to have this scenario like we had on the previous examples just now. You want to have an x squared, some b term, and then some space. So I'm just going to move this 3 over to the other side. It becomes a positive 3, but I'm not allowed to just add numbers to a problem. That's just not a thing. But I am allowed to add numbers to both sides of a problem. So once we figure out this number here, we're just going to add that number here on this side as well. Okay? So once you have your x squared, and then you have your x, and you have your plus space, and you've got everything else moved away, you're going to take your b term and cut it in half. Half of -2 is -1. And then you're going to square it. What I do to one side, I have to do to both, so I'm going to add -1 squared to that side as well. Please actually write it like this. Don't go ahead and put a +1, because writing it like this makes the factoring so very easy. I'm going to show you one time how to do the long way, and then I'm going to show you the shortcut. The long way is what multiplies to be 1 and adds to be -2. Well, that's x minus 1, x minus 1. Oops, I wouldn't say the square part. Yeah, and then I would say, oh, well, that's x minus 1 squared. Okay, I don't want to do that entire process. I want to just literally take whatever this is, put it here, and whatever this is, including its sign, and put it here and be done. I can skip this entire step if I leave my answer as -1 squared, because this -1 is what's being squared and x is what's being squared. And this middle will always be double because we forced that number. So don't do this process, just go straight here and here. Okay? Then on the right side, this is -1 squared is a positive 1, so 3 plus 1 is 4. Now we have that taking the square root method. So I'm just going to square root both sides. Left side is going to be absolute x minus 1. Right side is going to be a 2. I do have regular numbers and no square roots, so I'm going to go ahead and do my positive and negative route. X minus 1 equals a positive 2. And x minus 1 equals a -2. To solve both these, again, just add 1. So adding 1, I get a 3. Adding 1, I get a -1. Therefore, x equals -1 and 3. You would check your answer. I know it's a lot of work, but it will be quicker and you'll get better at these. You would check your answer by going back up here and plugging in a -1 in here, or plugging in a 3 in here. I would either store feature in your calculator, but whatever you got to do to check it, I would definitely go ahead and check those. All right, looking at our next example. Again, we have to have x squared by itself, and we want to have the x squared and the x term isolated. So this 8 is already over here, but I need to have an x squared, so I'm going to go ahead and divide every single term by the coefficient out front. Make sure you don't forget to divide the last term as well. So dividing every single thing by 2, I'm going to get x squared plus 10x. And because I now have x squared and x isolated, I'm going to go ahead and add some space. Please actually go ahead and follow along with me. These are ones, once you've seen like 4 or 5 examples, it's pretty easy, but it takes a minute to get the process. Okay, to figure out what's missing, I'm going to take my b term, cut it in half. Half of positive 10 is a positive 5, and then I'm going to square it. What I do to one side, I do to both. We're going to shortcut it. I want to factor this guy. He is always going to be whatever's here and whatever's here in the same sign. So he's a positive 5, so he's a positive 5. And then square your quantity, and you're done on that side. Super, super easy. This side, 4 plus 25 is 29. And now you have what you did on yesterday. Yeah, yesterday. So I'm going to go ahead and square root both sides. So the absolute value of x plus 5 equals, and then square root of 29 is just square root of 29. And because this guy is a radical, I can go ahead and do that positive, negative just in front of that absolute value. I'm sorry, in front of that square root. So how would I solve this? I would move 5 over by subtracting it. So my answer is -5 plus minus square root 29. And you could check that as well by plugging that in your calculator. Well, if you have a calculator or your phone or whatever. Okay, our next example. Again, I want to get x squared and x isolated, so move this 5 over. So 4x squared plus 40x equals 5. And I can't do that plus space until this guy is straight up an x squared. So whatever number's out front, divide by 4, divide by 4, divide by 4. Make sure it goes across the board. Okay, that's going to leave me x squared plus 10x. And now I do have an x squared and x, so I can go ahead and add space. And then 5 fourths is just 5 fourths. Leave that guy alone and plus space. Okay, then what is half of 10? Well, that's a positive 5 and square it. Half of 10 is a positive 5 and square it. Factoring this side, you just take whatever's here and whatever's here. And then don't forget to square your quantity. Over here, use a calculator. Do not make decimals. So this will be a little bit difficult for you without a calculator, but this ends up being 25, obviously. And then if you make them have the same denominator, 25 times 4 is 100. So this is 100 fourths. 100 divided by 4 is 25. So now I can just add 5 plus 100. So this is 105 fourths. You cannot square root decimals. You have to have a fraction. Because when I square root both sides, hopefully you can see it already, I'm going to get absolute x plus 5 equals, well, square root of 105 actually is 5 times 21, so that guy's stuck. But square root of 4 is 2. So that guy does get pulled out of that radical. And I do have that messy radical thing, so I can go ahead and make this guy my plus and my minus. So how do I solve this here? Well, I'm going to move that 5 over by subtracting. So I'm going to get x equals negative 5 plus or minus square root 105 over 2. And you just leave it like that and you're done. So nothing else needs to happen on this. I will talk about on the next example, or whichever one comes up next, about same denominators, but this guy's fine. Leave him alone. Plug him in, try him out. Okay, next example. Again, I want to get x squared and x isolated, so move that 3 over to the other side. Then I have to have an x squared, so because I don't have an x squared as is, I've got to divide by the coefficient out front, our leading coefficient. Just bring everything down. But now that I have an x squared and x, I can go ahead and add some space. Again, leave 3 halves as 3 halves. And add some space. So this one's a little messy, that's okay. What is half of 1? Half of 1 is 1/2. Square it. And then over here, exact same answer always. All right. So make it easy on yourself. This would be hard to factor if we weren't doing it this way. I'd say, oh, well, it's just an x, and it's just a positive 1/2. And that's it. Left side is done. I factored it and ready to go. Right side, this ends up being 1/4. You can make this guy also a fourth by multiplying by 2 over 2. So 6 fourths. 6 fourths plus 1/4 is 7 fourths. Square root both sides. Boom, bitty boom. I'm going to get absolute x plus 1/2 equals square root of 7 is stuck. Square root of 4 is just straight up 2. All right. Because this guy does have that radical, I can go ahead and do my positive negative in front of the radical and not actually write out both separate routes. So how do I solve this? I want to get rid of this positive 1/2, so I would minus it. So I would get x equals negative 1/2 plus or minus square root of 7 over 2. All right, so this one, because they have the same denominator, you are going to need to go ahead and just push those guys together. So literally just write one big 2 on the bottom, and then push together all the stuff on top. So negative 1 plus or minus root 7. So that's what your answer is going to be overall. All right, unfortunately, I do want to go ahead and do 1 or 2 more examples. So my video only lasts 15 minutes, so we'll need to go ahead and make a second video. But I'll go through those next few quickly. But I just want to make sure you guys can do these. These questions are a little hard if you haven't seen several of them worked out. So go ahead and watch the second video.